Hi everyone, so in this video we will talk about section 1.3, raised up chain and behavior of graphs. Array of chain describe how an output quantity change relative to the chain of input quantity. So the units of array of chain are output units per input unit. For a linear equation, the average rate of change is actually the slope of the linear equation. Okay, so the linear equation will have a form of y equal mx plus b. The graph is actually a linear line like this. Okay, this is a straight line. When x is goes 0, y is equal b. So when x equals 0 right here, y is actually equal b. So this value right here is the b. So let me say this is 0 and b. Okay, so that is called the y-intercept. When you have a non-change in x and the y quantity will be b. M is the slope, determine the steepness of the graph, okay, the steepness of the graph, because linear line can be like this way, or can be steeper, or can be less steeper. So slope is determine the steepness, or the rate of change is also determine the steepness, or how fast the function is growing, how slow is decreasing, or fast to decreasing. And the slope can be found by using rise over run. So the change in the y value over the change in the x value. So for the linear line, the slope m can be described as the rate of change, where if you got given 2 points, x1 and x1, y1, and x2, y2, then the slope will be f of x2 minus f of x1 over x2 minus x1. This is called the rate of change of the linear equation. How about for nonlinear equation? What is nonlinear equation? The red curve right here is actually called nonlinear, which is they are not straight line, they are a curve. So they are nonlinear. And the average rate of change of a nonlinear curve can be found by between 2 points, can be found by finding the slope of the straight line that go through the 2 points. Okay, so the line go through the 2 points is called the secant line and denote at secant. So this is the slope of the secant line. Go to 2 points on the curve is actually the average rate of change between 2 points on the curve. Okay, so let's try an example for how do we find the average rate of change of a nonlinear line within 2 different points. Okay,